Optimization questions, grade 12 mathematics. This is differential calculus mathematics paper 1. Right, let's have a look at how to answer this kind of questions. The diagram below shows the plan of a veranda which is to be built on the corner of a railing of a cottage. A railing A, B, C, D is to be constructed around the four edges of the veranda. If AB is equal to X, DE is also equal to X, BC is equal to Y, CD is also equal to Y, and the length of the railing must be 30 meters. We want to find the values of X and Y for which the area of the veranda will be maximum. Now, at the maximum or minimum of anything, the derivative is always equal to 0. So here we want to find the values that can give us the maximum value of the veranda. Now that means we must formulate an equation that represents the area of the veranda. Then we differentiate that equation, equate the derivative to 0, and solve for whatever variable you have. So once again, to determine the maximum or minimum values, you formulate an equation that represents the quantity that needs to be maximized or minimized. Then you differentiate that equation, equate the derivative to 0, and solve for X or for Y or for whatever variable is there, because you can get anything. In this case, I want to find the values of X that can ensure that we have the maximum area of the veranda. That means we must formulate an equation that represents the area of the veranda. If you look at the measurements that we have here, I have divided my shape into two. I'm going to find the area of this part plus the area of this part and add them to get the total area of the veranda. You may need to remember your grade 8, 9 measurements here. The area of this first part, the area of a rectangle is length times breadth, so that's xy. Then for this other part too that I've labeled here, the line from F to E, given that the line CD is equal to y and BA is equal to x, it means FE must be y minus x, which therefore means the area of this part is going to be x multiplied by y minus x. Now I can say the area of this veranda, the area of the veranda is equal to xy plus x multiplied by y minus x. Then we simplify this expression to simplest form, xy plus xy minus x squared. So this is equal to 2xy minus x squared. This is the area of my veranda. When you find the expression for the quantity you want to maximize, you must differentiate, equate to 0, and solve for x. Now, if your expression has two variables, like here, I have got x and y, you can't differentiate in that form. It means you must formulate another equation using the information provided, and that information will always be there. Then you substitute. In our case, we are told that the railing that is to be used for making this veranda is 30 meters long. It means the railing starts from A to B, that's X, B to C, that's Y, C to D, that's another Y, and D to E, that's X. If you add all those numbers, they must give us a total of 30 meters because the railing has got 30 meters. So we're going to add them. If you add x plus y plus y, it gives us a 2x plus 2y. This is equal to 30. Then simplifying this equation to simplest form by dividing by 2, we get x plus y is equal to 15. Then from there, making y the subject of the formula, y is equal to 15 minus x. Then we can say, all right, therefore, the area of our veranda, which is 2xy minus x squared, is equal to, we're going to take this y and replace it with 15 minus x. So this will become 2x, factor of 15 minus x, and then minus x squared. Simplifying to simplest form, this is basic algebra. The area is equal to 30x minus 2x squared, and then minus x squared. Finally, our area is equal to 30x minus 3x squared. This is the area. So what are we doing here? You formulate an equation that represents the quantity that you want to maximize. When you get that equation, you differentiate it. So we have got our equation and we have made sure that it is one variable. The next thing to do is to differentiate the area expression. So the derivative of the area, or dA dx, is equal to 30 minus 6x. After differentiating, equate the derivative to 0 and solve the resulting equation. So this will be minus 6x is equal to minus 30. Dividing both sides by negative 6, it gives us x is equal to 5. Now I need the value of y. Remember from our previous calculation, y is equal to 15 minus x, and x is equal to 5. Therefore, y is equal to 15 minus 5, which gives me y is equal to 10. So that is our answer. So we can now say for maximum, if we want to find the maximum area, then the value of x should equal to 5 and the value of y should equal to 10. Our question is answered. This is optimization questions calculus grade 12. So quickly to recap what we have done here. Number 1, you formulate an equation that represents the quantity that you need to maximize. Number 2, make sure your equation has got one variable. If there are more than one variables, you formulate another one and substitute and simplify to simplest form. After simplifying, differentiate, equate to 0, and solve for the variable that you have. That will give you the values that can lead you to the maximum or minimum value of whatever they are asking you to calculate. In this case, we want the maximum area of the veranda. X must equal to 5, y must equal to 10. Now, in some cases, they may say to you, what is the maximum value of the veranda? We now go back to where we calculated our veranda, and then you substitute. So these numbers that I got for x and y, they are the ones that can give me the maximum area of this veranda. But if I want the maximum value of the veranda, then I must go back to the veranda, which is in its simplest form before differentiation, in this form here. Then put the value of y that we calculated